Now, I do think in one of the videos today, we were taking a peek at the graph of that surface as well as the graph, as I recall, of this surface, and we were trying to observe the curve of intersection. Now, remember how the first one is just a cylinder. Actually, I need more room than that. X-axis. Y-axis, Z-axis. When we were in the XZ coordinate plane, we had a circle in that plane with the radius of 1 center located at 0, 1 as an ordered pair in 2 space. And we're sliding in the Z direction. Here's a cylinder we have, again doing a poor job. Understand that I really intend for you to see that this goes on in both directions indefinitely. Now the other one in the XYZ coordinate system. It also is a cylinder, but it kind of basically looks like a trough, because in the XZ coordinate plane, I get this parabola that gets slid along the y-axis. Looks something like that. And so when these two curves intersect, well, let me rephrase that. If I slide this one right here into the same coordinate plane as the same coordinate system, not plane, as this one to the right, then I do think I'm going to get a curved intersection. I think it's hard to see because I didn't draw both these surfaces in the same coordinate system. I think it's hard to see because I just don't do that good of a job of drawing. So if you don't mind, I'm going to cheat. I'm going to go online and steal a little bit of technology. Now, before I do, I think we did this in the video, I'm not sure. I can parameterize the curved intersection by noting that with the first equation. If I just allow x, whoops, sorry, I don't need that color, do I? If I allow x minus 1 and y to be the cosine of t and the sine of t respectively, or vice versa, then the first equation is nothing more than the restatement of the Pythagorean identity. Well, the first Pythagorean identity. But the second equation says that z is equal to whatever x is, which is this, quantity squared. And so I think as a vector-valued function, r bar t, the curved intersection of those two surfaces, can look like this. It's not the only representation, but it is certainly a representation. Whoops, I think I got my first one wrong. Isn't x 1 plus cosine of t? Y is a sine of t. Z is 1 plus cosine of t quantity squared. And let's, first things first, let's look at those surfaces in 3 space. So if you don't mind, I'm going to go online. I'm going to look at Geogebra. And with this program, I'm going to type in those two surfaces equations. It was, I think it was x minus 1. I take it back. Have a parentheses. Open parentheses, x minus 1. Squared plus y squared equals 1. So there is a vertical cylinder. The second one was, oh, it was quick. It was z equals x squared, I think. Now, I can't use my arrow keys on my keyboard, but I can do this. I can talk about taking one of these axes and with my pen, just rotating it. That was bad. So take a peek at this image. There is where the two surfaces intersect. I think I suggested in the video that the curve intersection, if you can try to visualize it, looks like it probably is some kind of a like a bent rubber band. I shouldn't say bent, an arced rubber band. That's what it's looking like to me when I see the cylinder, the trough, intersecting the cylinder that's a vertical tube. Now, because it's so darn difficult to see, let me get out of this program and use another program that allows me to sketch the graph. A vector valued function instead. Now, as I recall, changing my equation, I'm just going to come over here and edit the equations that are there. I have no idea what this program is, everybody. Every time I do this, I just go online and whichever one looks, the first one that looks easiest to use, I use. So it does say Christopher Chudzicki, github.io. Okay. So if I can just change this to, you know what? I think I need my keyboard. Hold on a moment. All right, that'll make my life easier. So I believe it was 1 plus. No, I don't think it was. Yeah, it was 1 plus. When I removed the parameter. Gosh, I wish I had a better memory. My goodness. I think y was just a straightforward sine of t. And let's see, z should be the same thing as x, but quantity squared. So open parentheses. Whoops. I said open parentheses. 1 plus cosine of t. Just being careful and abiding by its syntax. And that should be squared. I hope it uses a caret key. And let's see if it'll graph it for me. Oh, there it is. So I guess I was right. In the end, it looks like a rubber band kind of wrapping around that vertical cylinder. There is my curve of intersection. Actually, what I'm doing right now is not using my arrow keys. I'm just kind of messing with my pen being hooked on one of the axes, actually at any point in the XY coordinate plane, and just rotating it into any desired degree I like. So everybody, I hope this is helping. I just think I did a terrible job with the visuals today. Oh, by the way, if you look at that black thing on there, that's just your vector valued function tracing out the curve as a parameter t increases. I'm outsmarted by a program.